This is Leetcode 15, 3-sum. This is one of the most popular Leetcode questions. It has 10 million submissions. So we are given an integer array nums, and we need to return all the triplets. The triplet is defined as nums I, j, k, such that all the elements are unique, and they add up to 0. We need to note that the solution set must not contain duplicate triplets. Given a question like this, the first approach we can easily come up with the brute force approach. Basically get all the combination from the array, because we are talking about 3 elements. So the time complexity is n cubed. But now I'm going to talk about 2 points, which take n squared. Because the question says the order of the output and triplets does not matter, we can easily sort the array. This will prevent us to get the duplicate. Now, the reason is that this is called 2 points approach is that while we are doing the comparisons, it's actually j and k are doing the moving. So if the sum is less than 0, because we sort the array, that means we need to move j to the right to find the larger element so that we can bring the sum to approach 0. Same as if the sum is greater than 0, that means the sum is too large. So we need to move k, which is the largest element, to the left. And if we find a match, that sum is equal to 0, then we add the sum to the result. And this is the Python code. First, we need to sort the nums, and then we declare the results as the set because we don't want to have any duplicates. As I is going to the right, we declare j as I plus 1 and then k as the last element. While j less than k, that means we are still on the search of the sub-array. We come up with the sum, and then every time we check if the sum is greater, less than, or equal to 0. If we find a match, then we can move j to the right and then k to the left. Otherwise, if sum is too small, that means we need to find the larger num. And because we sort the array, that means the j needs to move right. And same as k, if we find a less element, then k needs to move to the left.